So hello everyone. Today we are gonna discuss how is memory maintained and in memory managed when we use a variable, and then we'll discuss about the pointers. So for example, first concept, just in general programming, I'm not writing the exact word. In between you write a line int a equal to 5 or 50 and terminator. What is this exactly done? First of all, let me tell you, the computer itself contains a lot of the memories are they are present in the computer, and just we give names. For example, this is a lot of memory, this is a group of memory. I'm just dividing it into boxes manually. So what happens is these memory are represented by addresses. What kind of addresses? Just a second. For example, the address of this is 200. The next memory will be 201. The next one will be 202. The next one will be 203. So, in general, any data type such as integer requires 2 or 4 bytes depending upon the environment. So, we don't really write this. For example, if this is 200, this will be 204, this will be 208. This the address what I'm telling, they are arbitrarily, that they may be anything, but we are just gonna so sorry for the time gap. So what I was telling was these memories are maintained in the form of blocks. So but these memory addresses are not 200 or 400. They might be anything. We can see what they are. They are generally stored in the form of hexadecimal numbers, but these are addresses and they are in the form of numbers. So for example, this is a block 200. This is 204. For when we assign, for example, int a equal to 50. So what happens over here? The compiler search for the memory. For example, it got this 200. This is chosen by the compiler. If this got this 200, then within this box, the value of 50 is stored, and this box is given the name A. So when using this line, when we are doing this, the value a is given to this box, which has the address 200 in this case, and the value 50. So this is the concept. This 200 is the address. So the next concept, what a pointer is. What is a pointer? Pointer is simply a variable which stores the address of another variable. So what does this line mean? It means that this a is storing a 50 value. This a is a variable. This contains a value or a literal, if we call it exactly. And so, but the address of a, say, which is 200, this can be also stored, and this is stored with the help of a pointer. So what is the syntax? Int it is written the same as variables, but just an asterisk is added before or after the variable name. For example, asterisk p. This is the declaration of a pointer. But how do we define it? Remember, while scanning, I told you that we don't put the variable name, instead the address. So what? So here we can do int p equal to m% a terminator. So this p is a pointer which stores the value of the address of a. So this is the thing. Or instead we can file declarative, we write does this, and then p equal to, here we declared p is a pointer. So the next time we don't need to write asterisk p. Here p is equal to m% a. This is the correct syntax. Okay. So for example, I'm gonna show you a demo. Just making a simple program, include stdio.h void main. Okay. So here int a. For example, we are scanning, we are not assigning any values, or we can assign. Let's int a equal to 50. Int asterisk p. This is a pointer equal to address of a. Printf we're printing it in the form of a number and p. I think it might throw an okay. This came. So this is a number, this is an address. Okay. So, but it is not generally used as this. Instead of percentage d, we can write percentage x. It returned in the form of a hexadecimal number. This is an hexadecimal number. Okay, whatever percentage p. These all are format specifiers. This is also a hexadecimal number. So how to use it? For example, if this ampersand is called the reference operator, so it contains the address of it. Let me show you another use of this thing. What if we don't define it over here? If we want to scan it or take the input from the user, then we can write in general scanf. What do we write? Percentage d address of a. That's what we write to take input. So instead of address of a, you can simply use this p pointer, because p already contains the address of a, and we are printing, we want to check if that's what happened. Percent d and a, we are checking if a is contained the value that we inputted. Okay, so we are running this program. Number, it is asking for a value. I wrote 599 and 599 is printed. So this pointer works as an address to an a, to the variable a. So what I was telling, this ampersand is called the reference operator. So referencing is quite actually good, but what about if you want, we have that address and we want what is in that address. For example, we just have p, and this p is this memory block pointed to this memory block which contains 200. Okay, so we have just got p, and what we want, what's value in it. So what are we gonna do? Sorry for this mistake. Actually, integer doesn't. Yeah, no. Okay, it's okay. Oh, I was about to tell that integer takes more than 1 byte, so after it won't only occupy 200, might occupy 200 to 1 and 2, 3 as well. So, but it's okay. So, how are we gonna dereference it? So, for dereferencing, this asterisk operator is used. So, it is called a dereference operator. For example, just to divide it. For example, int a equal to 5, int asterisk p equal to address of a, but we want to print the value what is stored in the a variable, that means in the memory location p. So how are we gonna do that? Here we are gonna write printf %d. Look, p is an address, but we don't want to print the address, we're gonna print the value in it. So this asterisk will give the value. This is called value at operator or dereference operator. So we're going to try this as well. For example, we are printing a, that means value at p, because p has got the value that is variable a. So we're going to test this as well. We entered the value 67 and 67 is returned. So this works. Basically, this is how pointer works. So there are some different extreme cases. For example, there are double pointers, which means these pointers store the value of different pointers. For example, where I'm writing an example over here. I'm changing the font to small size. Int a equal to 10, int asterisk p equal to address of a. And we want to, since p is also an address, it's also, but it is a value, so it's also stored in some other location. So we can use a double pointer, int asterisk q, this is a double pointer, equal to address of p. This means that this queue contains a value which is an address, this p, and this p is also an address which contains the value a. P contains the address of a. So how are we gonna print this? If you want to print this, we can use, if you wanna print this using q, then percent d. This will be double dereference operator, value at q. So this will work. So we are gonna try this as well. In this case I'm just gonna define it equal to 100. Suppose p is equal to address int double star p q equal to address of p. This q is storing the value, sorry, the address of p, and this p is also containing the address of a, and a is containing a value 100. So if we just write simple d value at q, this will show the address of p, but we won't want that. We are not concerned with the address over here, we are concerned with the value. So we are gonna use this double asterisk q, and we are gonna run this. 100 should come, and 100 has come. So this worked. So basically this is the basic of pointers. This is all for today, this video. Hope you see you again.